Okay, so now if we have a function like this, y is equal to f of x, now instead of adding c units to the function f of x itself, we're adding c units to our variable x inside of our function, right? So now in this case, we're adding c units to the variable x. So what happens to the graph of our function y is equal to f of x, right? How do we graph this function? So if c is greater than or equal to 0, then the graph of this function gets shifted to the left by c units, right? So there is a horizontal shift to the left by c units, and if c is less than 0, then similarly the graph of this function gets shifted to the right by c units horizontally. Right, so if we take a look at some actual examples, so let's say we have a function, we have x squared, right? So if we have y is equal to x squared, and then we have another function y is equal to f of x, which is equal to x minus 2 squared, right? So in this case, we're adding negative 2 to our x, so c is equal to minus 2. So in this case, what happens to the graph for this function? To graph this function, we're just going to shift the graph of this function 2 units to the right, right? We're going to shift the graph of this function by 2 units to the right. So if we draw the graph of x squared, so this is our graph of x squared, and we know that the vertex of this graph is at the origin, which has coordinates 0, 0. So this is our vertex of this graph, of this parabola. So since we have x minus 2 whole squared, this graph gets shifted to the right by 2 units. So for the graph of y is equal to f of x is equal to x squared, our vertex is at 0, 0, and for this function, our graph, the vertex of this graph will be at 2, 0, right? So there was an increase by 2 units to our x coordinates, right? Since we're shifting the graph of x squared by 2 units to the right horizontally, then each of the x coordinates of all of these points will have an increase of 2 units. So the x coordinates will be increased by 2 units. So in this case, our graph will look like this, right? So let's say if x is equal to 2, we will get y is equal to 4 for this function, right? And for the same output, over here we will have y is equal to 4. So let's say this is 2, 4, right? Then for the same output in this graph, our corresponding input will be 4, right? So this is 4, 4, and this is 2, 4. So the x coordinate of this point just increased by 2 units, and it gives us 4, 4, right? So let's say we have x is equal to 2, or let's say x is equal to 3, for example. If x is equal to 3, then obviously y will be equal to 3 squared, which is 9, right? So if this point is 3, 9, then similarly, for this graph, we will have a corresponding point 5, 9, right? So once again, the x coordinate increased by 2 units to give us the same output. And we can check this as well. So when x is equal to 5, we have f of 5 is equal to 5 minus 2 whole squared. This gives us 3 squared, which is equal to 9. So this is equal to 9. So when x is equal to 5, we have 9. And instead, if we had x plus 2 whole squared, then the graph of this function, so this is just the graph of x squared again, then this graph just gets shifted to the left instead, right? Since we're adding 2 units and 2 is positive, right? So we're shifting the graph of this by 2 units to the left. And in this case, our vertex will be minus 2, 0. And our graph will look something like this. Right, so this is just some of the graph transformation rules. Now, before we move on to try and graph some functions, let's take a look at the very first function that we discussed once again. So we have a linear function. Let's say this is y is equal to x plus 2, right? So sometimes a graph can have an x-intercept and a y-intercept. So graphs can have an x-intercept and a y-intercept, right? So what is an x-intercept? An x-intercept is just basically the point where the graph of a function crosses our x-axis, right? So we have to look for a point where the graph crosses our x-axis. So for the graph of this function, we have an x-intercept at this point, right? And similarly for the y-intercept, we will look at the point at which our graph intersects the y-axis, right? So we will look for a point where the graph intersects our y-axis, and that will be this point over here, right? Now, how do we find the x-intercept and how do we find the y-intercept? So we know that for any x-intercept, the y-coordinate will always be 0, right? So for any point on our x-axis, the y-coordinate is 0. So in order to find the x-intercept, we can just set y to be equal to 0, and then we can solve this equation here. We can solve the function for x. So when f of x is equal to x plus 2, we set y to be equal to 0. So we have 0 is equal to x plus 2, right? So now solving this equation for x, we have x is equal to minus 2, right? So our x-intercept will be at the point where we have the x-coordinate to be minus 2, and the corresponding y-coordinate will be 0, since we're setting y to be equal to 0, right? So this point will be minus 2, 0, and this is our x-intercept. Now similarly for the y-intercept, so any point on the y-axis will have the x-coordinate 0, right? So to find the y-intercept, we set x to be equal to 0. So now our function is f of x is equal to x plus 2. So when x is equal to 0, we have f of 0 is equal to 0 plus 2, which is just 2, right? So in this case, y is equal to 2 when x is equal to 0. So our y-intercept will be 0, 2, right? So this y-intercept will have the coordinate 0, 2. Right, so whenever we try and find the x-intercept, we set y to be equal to 0 and solve the function for the value of x. And when we want to find the y-intercept, we set x to be equal to 0 and we find the value of y. Right, so now let's take a look at some function. We have f of x is equal to x minus 6 whole squared minus 4. Right, so now once again from the graph transformation rules, we can draw this function. We can draw the graph of this function. So we see that, so let's consider f of x is equal to x squared, right? This is a parabolic function, and we also know that this function is parabolic because if we expanded x minus 6 whole squared, we will get some x squared term, right? So these are both parabolic functions. So now in this case, we're subtracting c units from our x variable, and in this case c is equal to minus 6. Sorry, so we're adding c units to our x variable and c is equal to minus 6. So what happens in this case, since c is less than 0, we're shifting the graph horizontally to the right by 6 units, right? So if we have the graph of x squared once again, right? So this is the graph of x squared, and the vertex is at 0, 0, so which is this point, right? So we're just shifting this graph by 6 units to the right. So we will have, so if this is x is equal to 6, now we also have -4 being subtracted from our function, right? And that means that we're going to shift the graph 4 units downwards. So we will go 4 units down, and this will be our vertex, right? So this is -4, this is x is equal to 6, and this point will be our vertex, right? Now, if we want to graph the function of this, it is easier if we find the x and y intercepts. We can draw a more accurate graph if we find the x and y intercepts of this function. So let's try and find the x and y intercepts. Right, so to find the x intercept, what do? We just set y to be equal to 0, right? So we know y is equal to f of x, and if we set y to be equal to 0, then we have x minus 6 whole squared minus 4, and this is equal to 0. Right, so now we solve this equation for x, so we have x minus 6 whole squared is equal to 4. We take the square root of both sides. This gives us x minus 6 is equal to 2. And now we have two separate equations. So now we have this should have been, since we're taking the square root of both sides, we have x minus 6 is equal to plus or minus square root of 4, which is just equal to plus or minus 2. Right, and then this gives us x minus 6 is equal to 2, or x minus 6 is equal to minus 2. Right, so solving each of these equations for x, we have x is equal to 8, or we have x is equal to 4. Right, we have 6 minus 2, we have 4. So we have these two values of x. So our x-intercepts will be 8, 0 and 4, 0. Right, obviously the y-coordinate will be 0 for our x-intercepts. So we can plot these points on our graph. So let's say this point is 8, 0, and let's say this point is 4, 0. Now let's try and find the y-intercept. Right, so let's find the y-intercept. Right, so for finding the y-intercept, we set x to be equal to 0. Right, so once again, our function was x minus 6 whole squared minus 4. So when we set x to be equal to 0, we have f of 0 is equal to minus 6 whole squared minus 4. So we have 36 minus 4, which gives us 32. So when x is equal to 0, y is equal to 32, and this will be our y-intercept. Right, so we plot this point on our graph. So we will have, so let's say this point is 0, 32, our y-intercept. So now we can draw the graph more accurately, right? So we can draw the graph going through our x-intercepts. Let's say our other x-intercept is at this point. So this is 4, 0. Okay, so this is obviously a very poorly drawn graph, but hopefully you guys understand the idea of what's going on here, right? So this point will be 0, 32, which is our y-intercept. And these points will be our x-intercept. Right, so let's take a look at a different graph. So let's say we have f of x is equal to 4. Right, so let's try and graph this function. So this just means y is equal to 4. So now you can see that for any value of x, our output is always 4. Right, so no matter what value of x that we take, our output is always giving us 4, right? So to graph this function, it will just be a straight line that is horizontal, and each of these points will have the same y coordinate. For any value of x, we will have the same value of y, right? So if we try and find the x-intercept, we can see that we can try and set y to be equal to 0, but we know that y can never be equal to 0 according to this function, right? We see that the output is always equal to 4. So in this case, there is no x-intercept. So we have no x-intercept, right? This graph never approaches our x-axis. And for our y-intercept, we can set x to be equal to 0, and you will see that f of 0 is giving us 4, right? So our y-intercept is 0, 4, which is going to be this point, 0, 4. So this is our x and y-intercept, and this is the graph of f of x is equal to 4.